Well, hello there. It's been a while, but tonight we're going to be discussing atoms in the periodic table. Our objectives for tonight: we want to be able to understand vocabulary of the periodic table, explain how elements can be found in the periodic table, and identify the basic building blocks of the atom. We also want to be able to locate where elements of the periodic table can be found. Well, first of all, atoms. Um, Atoms are represented in the periodic table by their chemical symbol. Typically, what will happen is when it comes to the periodic table, you'll have a box, and in the middle of it is the letter, and that's its chemical symbol. That's a shorthand way to write the name of an element. Examples of this is some of them will have one of them is O for oxygen or Ag for silver. This N would be for nitrogen. Atoms. Atoms are the basic building blocks of matter. Nothing can be broken down farther and still be the same material. Still talking about atoms. At the center of an atom, we have a nucleus, and it has a positive charge because in the center of an atom we have these protons and we have neutrons. These neutrons have no charge, so I'm just going to use an N to represent them. It doesn't really matter how many neutrons you put in there because they don't have a charge. So the only charge in here right now is this nucleus would be plus 4. The protons are positively charged masses in the nucleus. They have the same mass as a neutron relatively, and they have an atomic mass of 1 U, meaning they're 1 unit. On to the next topic here then, electrons. Electrons float around in shells around the nucleus. They're equal but the opposite charge as a proton. They are negatively charged, and they are 1/2000th the mass of a proton or neutron. So although they have the same charge, they don't have anywhere near the same amount of mass. So you'd have a nucleus, and I'm just going to have a dense black thing here representing the nucleus, and then floating around the nucleus, you'd have these negative charges, and they could be all over the place. Right, and later on, we'll tell you a little bit more about that area that those electrons can be found. Next thing I want to talk about here is the atomic number. Atomic number is the number of protons in a nucleus. All alike atoms have the same atomic number. An example of that is all carbon atoms have 6 protons. This number tells us of an electrons in a neutral atom. So let's talk about this carbon atom. I know that in the nucleus it's going to have 6 protons. And whereas we typically know on average how many neutrons are going to be, there's no specific amount that has to be there. I'm just going to draw 5 to start off with. There could be 6, there could be 4, there could be 8. We'll get into more detail about that in the days to come. Here's what I want to talk about is the electrons in a neutral atom. Well, why would it be neutral? Because it has the same amount of protons as it does electrons, and that's what makes it neutral. It's got 6 negatives, 6 positives, so this is a neutral atom, or just an atom as we'll refer to it later on. The atomic number specifically, now that we've talked about it a little bit, is found typically right up here above it in the periodic table. For example, carbon would look like this. Oh, not a 6 there, sorry. They would have a C there and have a 6 at the top. C would be its chemical symbol for carbon, and 6 at the top would be telling us its atomic number. Tomorrow in class we're going to show a video that describes more about Bohr's model in the electron cloud model. But for right now we're going to leave it a little bit open. Remind me about that and we'll make sure we discuss that. Let's talk about the nucleus. The nucleus is very dense and small. Imagine a paperclip in the side, in the middle of the Sean Kimmel Track and Field Stadium we have here. That paperclip would be virtually undetectable. It would be very hard for me to put if I put a paperclip out there and said, "All right, your job is to go out there and find that paperclip." It would be virtually impossible for someone to find this specific paperclip that I put out there. That's what I want you to know about a nucleus. The nucleus is relatively unbelievably small when compared to the overall size of an atom. Well, let's talk about what's floating around the nucleus. Around the nucleus, we have these electrons. Electrons are found in shells or levels around the nucleus. Sometimes they're called energy shells, sometimes they're called energy levels. I'm sure we'll have another name for them at some point too. Um, I want you to realize that ones that are close to the nucleus have low energy. Ones that are far away have high energy. So these energy levels. Well, I'm just going to draw a dot here. Let's imagine this dot's a nucleus. So that's where all the protons and neutrons are. Around this now we have these energy levels. And you see this sometimes. They show these loops, all right, that go around here. Well, let's talk about these energy levels. Row 1, all right, is commonly the one closest here. And you'll notice that it typically, or not typically, but always has at most 2 electrons in its outermost shell. Row 3 is going to have 8 in its outermost shell. So there'd be 2, maybe 4, 5, 6, 7, 8. It's got 8 electrons in its outermost shell. Row 3 is exactly the same. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I've shown it like this. Another way that it's commonly shown to you is just in a flat view, where they make this a real simple circle. And it's put some electrons. So there's 2 electrons there. This next one then would have 8 electrons. There's its 8 electrons, and then the next energy level would have the same 8 electrons in it. So we can see. Now, this 4th row, which I haven't drawn, this 4th row, this would be where we start to get things become a little bit different, and we start to talk about rows S and P and D, and we won't go into much detail about that. We won't go into any detail. Just know that even though it's got these subshells, that there are 18 total electrons in that row, in that energy level, in that shell. However you want to describe it, there's going to be 18 in that energy level. All right. Order of the periodic table. Periods are the columns. So in the periodic table, this is what it looks like approximately. In this periodic table, we have these columns. And I'm gonna negate talking about this area right here right now. This is where we call the transitional elements, and everything I'm going to discuss is going to be as if that part of the periodic table wasn't even there. So what this tells us then is when we talk about period, these are our periods. These columns right here, these are our periods. So if we were to say period 1, period 2, period 3, and so forth, these would be the periods, and that's equal to the electrons they have in the outermost shell. And that's why I say here the purple, didn't really do that here, that's the transitional not included. We're not really discussing those right now. Groups are the rows. Well, we have the periodic table is organized like this, and these are our groups. And that pretty much describes the periodic table for right now. Know that the periods are the columns and the groups are the rows. Hey, I'll see you on the flip side.